Hello everyone, welcome back to MacroLearning. So we're still in the organic chemistry alkanes. And here we have some more examples for the IUPAC naming of alkane molecules. 8 of them, so we'll do first 4 in this video and we'll take care of the rest in the next video. So let's go ahead and take a look at the first one. This structure is the kind of structure that's often used when you try to include a structure in your text. It's good, but when it comes to naming, you always want to draw out the full structure. Okay, the full structure. Now it's 2 methyl groups on the CH. Right? And 2 CH2 groups and another CH bearing 2 methyl groups. Okay, hope that makes sense to you. And from now on it's pretty straightforward. The main chain simply is this one here. It's 6 carbon chain, which is hexane, right? And the substituents are these 2 methyl groups. And when it comes to numbering, it really doesn't matter which side we start the numbering from, because it's kind of symmetrical, right? Either way, the 2 methyl groups will receive the same numbers, which is, if we start from the left, it's 2, 3, 4, 5, or it's going to be 5 and 2 if we start numbering from the right hand side. Okay, that's that. It's 2 methyl groups. How do we call that? One on carbon 2 and the other on carbon 5. 2, 5. 2 methyls. What do we say? Dimethyl hexane. Right? Okay, next one. Okay, the main chain for this one obviously is here, and we have, I think, 4 substituents, these 3 methyl groups, this 1 ethyl group. Now the question is how we do the numbering. Do we start from the left or the right? This is where it gets interesting, because whichever way you start, whichever side you start from, for the numbering, you always have a substituent that's going to receive the lowest possible number. So in this case, we will use the alphabetical order. Okay, where you can't decide the which way to do the numbering because of the symmetry like this. You have to use the alphabetical order to determine it. So in this case, it's going to start from the right hand side, go 1, 2, 3, 4, because the rule is that the alphabetically higher priority substituent is going to receive the lower number. Okay, so that means we'll start numbering from this end and give this carbon a number 3, 4, 5 for these 2 methyl groups, 6, 7 for this final methyl group. See, if we started numbering from this end, then the alphabetically highest priority group, the ethyl group, will be on carbon number 7, and that's against the rule. Okay, so now we have substituents and the numbers. Sorry, I apologize. I forgot. The main chain is called what? It's a 9 carbon main chain, which is a nonane. And so we call the ethyl group first, again because it's alphabetically the higher priority substituent. It's 3-ethyl. Three methyl groups, 2 on the 5th carbon and the other one on the 7th carbon. So it's 5, 5, and 7. 3 methyl groups, so it's trimethyl nonane. Okay, so this is just as you see, an example where the alphabetical order determines not only the order in which we write out the name, but it also determines the numbering for each substituent. Okay, hope you see the point here. Now the next one. Okay, so here the main chain would go like this. Remember, it's always the longest chain that you can find in the molecule. So this is a 7 carbon main chain, so it's gonna be a heptane. Okay, so now these substituents are 1 methyl group and 1 ethyl group. So how do we number the main chain? We'll start the numbering from this end and go 1, 2, 3. 3 for this methyl group, and carbon number 4 for this ethyl group. Because this way, the first substituent that we see along the chain will receive the lowest possible carbon number. If we start from this end instead, then it's not going to be the case anymore. So we'll do numbering like this, and then that's that. It's 4-ethyl. Ethyl has higher priority alphabetically, so we put it first. 4-ethyl, 3-methyl heptane. That's it. So now the again, the numbering is not determined by the alphabetical order. Only the order in which these two appears before heptane has to do with the alphabetical order. Okay, very nice. The next one. Okay, the last one in this video. Let's pick the main chain. Well, actually, I think there are more than one possibility for the main chain. Let me show the copy of the same structure. So the main chain, it will be tempting to have the main chain as this, right? But it could also be this. So in both cases, it's octane because it's 8 carbon main chain. 8 carbon main chain. So it's going to be an octane. But the thing is, which one is the right main chain? Let's see. The rule says that the one that has got the most branches is the correct main chain. In other words, the highest number of substituents determines the right main chain. So I'm circling out the substituents for both cases. In this case, if this were the main chain, we would have 4 substituents, 4 branches, But in this case, we're going to only have 3 branches. Alright, so that's it. If there's a difference in the number of branches, the number of branches is the deciding factor when it comes to which one is the right main chain. So this one is correct. Let's get rid of the other one and wipe out thing real quick. Just a second. Okay, so we got the substituents, the main chain, which is an octane. So what about the numbering for the substituent? And let's see. Numbering will go from this end, right? Go 1, 2, 3, 4, 5, 6, 7, 8, because this way the first substituent receives the lowest number again. It's number 2. Sorry, meant to use the other color. This substituent is on number 2. If we started the numbering from this side, then the closest substituent will be on carbon number 3. So it's not, it's against the rule. So given that this carbon, this methyl is on number 2, this ethyl is on number 3, and these two guys are on number 4, 5, 6, carbon number 6. So it's 2 ethyl groups. Ethyl will go in the front because of the alphabetical priority. So it's 3, 6 diethyl, right? And 2 methyl groups on carbon 2 and carbon 6, so it's 2, 6 dimethyl octane. Okay, 3, 6 diethyl, 2, 6 dimethyl octane. Alright, that concludes this part of the nomenclature question. Thank you for watching and see you in the next video.